Hello, Honor Chem students. I want to talk a little bit about the dissolving process that you had watched in the earlier video, and you also had read about as far as what happens when the water molecules are in contact with the solute. So the solvent in this case is the water molecules, and this ionic crystal would be the solute. And when they make a solution, if this water attraction to this anion is greater than this cation-anion attraction, we'd say that the salt would be soluble in water. And what happens is that the water is able to pull off this anion from this crystal lattice, as it's showing right here. And notice specifically that the partial negative portion of the partial positive portion of the water molecule is attracted to the negative anion. And then on a cation, the water orientates itself with the partial negative side of the water molecule being attracted to the cation. And that's what allows for dissolving of an ionic compound to happen specifically. There's actually what we call a dissociation, and we're going to talk more about that. This hydration shell right here is really just showing that there's water that is like kind of hydrating around the ion, and that's why it's called a hydration shell. And that is what keeps the cation and the anion from being attracted to each other. They basically will bounce off of each other because you have these water hydration shells, if you see an animation of it. The other thing to talk about is, let's go back to the factors affecting the rate of dissolving. If we increase the temperature, the water molecules in the solvent are going to be moving faster, which allows for more collisions with the solute, increases the dissolving. If we stir the water molecules, there's going to be more opportunities to come in contact with the solute, increases the dissolving. And then finally, if we were to grind this up and have a larger surface area, the water molecules would be able to come in the surface of the ions much easier than like the stuff that's way deep inside here. So it's going to also increase the rate of dissolving. Okay, so, well, let's talk about really how we can look at this, what happens when ionic compounds dissolve in water, they dissociate, and how we can draw that and how we can do math problems knowing this concept. Okay, so here I've got a beaker of water and I've got some solute in here, it's sodium chloride, and on a molecular level you can see that here's the solid sodium chloride, and at the surface the water is being able to rip off and break up the cation and the anion crystal structure of the sodium chloride, okay? Well, what would happen if I asked you guys, like if I said, hey, let's draw a picture of what this looks like in a beaker. So if I asked you guys to draw a picture of what this looks like, you would draw, here's my beaker, here is the solvent, which is water, and you would draw the sodium ions and the chloride ions breaking up. So we do that just by drawing a cation and the anion as far as how they break up. And so you could show maybe more than one formula unit here, and there you go. That's what it would look like, okay? What about doing some math problems with it? What if you made a 1 molar solution of sodium chloride? What would be the concentration of sodium ions? Well, the first thing that you're going to want to do is you're going to want to draw what we call the dissociation equation, and that's where you're going to draw the formula for sodium chloride, and then you're going to show how it breaks up into ion forms. It's a pretty simple chemical formula, so there it is. Here you can see the sodium chloride, and then I'm showing that it's breaking up into the sodium ion. There should be a plus sign here, so let's put that in, and the chloride ion. So it's a pretty simple chemical equation. I'm just showing you the breakup of really what you're seeing here in the beaker. Now, if this is 1 molar, then the sodium concentration is also going to be 1 molar. So even though this has two components, when they break up, you'll notice the mole ratio between all of these ions and the parent formula is a 1-to-1. So if this is 1 molar, this is 1 molar. Same kind of thing here is I've got an old flash drive here that actually has a clip on it. This together is 1 unit. So let's say that this is in all essence going to be my 1 molar sodium chloride molecule in a beaker of water. When I put this in water, they're going to dissociate. So what's going to happen, and I wish I would have brought my water molecules home that I have at school, but I don't, so we're improvising. So what happens is they're going to break apart and they're now going to be just kind of floating around in this water, and this is 1 molar sodium ion. This would be the 1 molar chloride ion. So they break apart and they dissociate, okay? All right, so now not everything exists in a 1-to-1 ratio. What happens when 0.5 molar cobalt-2 nitrate is dissolved in water? What would that look like in this beaker? Okay, well, let's see. Let's draw some water. So here is my water that I'm going to draw. And the cobalt nitrate would have a cobalt with a +2. But now there's 2 nitrates for every 1 cobalt in that formula. So I'm going to draw 2 nitrates for every 1 cobalt. If I were to write this dissociation reaction, it would be cobalt nitrate and that's going to break up into the cobalt ion, and I would have 2 NO3s with a -1 charge. Do you guys remember? Those are called nitrates. If this is 0.5 molar, that means the cobalt ion concentration is 0.5 molar. And the nitrate ion concentration is 1 molar. That's because for every one of these dissociating, 2 nitrates, as you can see here, are going to dissociate. It's time for you to try. So I want you to draw a picture of what happens. So in a beaker, what's going to happen when 1 molar iron 3 chloride reacts with water. And then I want you to tell me what is the concentration and this bracket means concentration. So what is the concentration of chloride ions? Okay, so that's going to be a question mark here. What is the concentration of chloride ions? That's what that means. After that dissociation, hit pause, do the work, and then I'm going to show you the answer. Okay, so I'm back. And do you have a picture that looks like this? Do you have an iron +3 with 3 chloride ions in your water? And did you write the dissociation equation to look like this? It would have 1 molar FeCl3, and when it dissociates, that means it would be 1 molar iron 3, and you would have 3 molars of chloride ions. Okay, so that is dissociation. You're going to want to watch the next video, which will be about how to do molarity with ionic compound solutions and a little bit more stoichiometry. So watch that. See you there.